So now we're going to talk about a stretch or compression. And so the form is f of x equals a log base b of x. If the absolute value of a is greater than 1, it's going to be a stretch. And if the absolute value of a is between 1 and 0, so between 0 and 1, it's going to be a compression. So similar to what we've done in the past. All right, so let's look at the example. Sketch a graph of, and they give us this function, 2 times log base 4 of x alongside its parent function. So let's get the parent function. The parent function would be g of x equals log base 4 of x. Now, I'm going to go ahead and do a table of values here, just a little one. So you know if you have 0 for the output, that you're getting 1, right? So that was one of our points, the x-intercept, 1, 0. And then the key point, so this is the x-intercept right here. And then the key point, I'm just going to do these 2 points, is going to be 4, because that's b, 1. And then you could do a table of values like we did in the other examples with more points, but I'm not going to this time. I'm just going to have those. So we know for the parent function, we know here's the asymptote. We know it goes through the x-axis at 1, 0, and then that other key point is at 4, 1. Okay, so we know it's going like this. You know, something like that. That would be the shape. Now, what's going to happen when we multiply things by 2? Well, it's going to stretch, right? So let's graph this then in black. So if we had x f of x, now we're going to have 1, 0 still, because if you multiply 0 by 2, you know, that's still going to be 0. And then you're going to have 4, 2. All right, what happens if we have like something smaller than 1? We didn't do that on the parent function. I said I was going to skip that. Now I'm changing my mind. Okay, so let's say we put in like a -1, and we would get 1/4, right? Okay, so that would be, well, it's going to be like there. Kind of missed it with my graphing. Yeah, I missed some of the points. Okay, but now what would happen if I stretched that? If I multiplied the output by 2, I would have 1/4 -2. Now let's see what that means. It means I'm going to have 1/4, but it's going to be down lower. So it should be underneath, or I'm sorry, not underneath, to the left of the curve. Then it's going to go through the point 1, 0, same x-intercept, and then it's going to go above. So I should have 4, 2 up here. 4, 2. I can't get it to draw. Well, it's going to draw. There it is. You know what? I think I told you wrong. I think it's going to be to the right. So it should be over here. It's really hard to see. But it's going to come up and go like this. There's a better picture in the book. Okay, so it's going to look something like that. At some point, they kind of start running the lines together. There's a much better picture in the textbook of what that looks like. But it should be crossing over, so it should be to the right here. I'll try to exaggerate it a little bit. And then it should be above after it goes through the x-intercept. Okay? All right. But the asymptote's still the same, even though I have it kind of drawn funny. Okay, so what's the domain? The domain is still going to be from 0 to infinity. And the range is going to still be all real numbers. And the asymptote's still going to be that vertical asymptote. I didn't draw it, but there it is. It's the same. X equals 0.